This module introduces geospatial machine learning with Python. The module consists of 10 labs. So lab 1 is going to introduce geospatial machine learning with Python. Lab 2 will look at Python fundamentals for geospatial machine learning. Lab 3, we are going to look at the fundamentals of machine learning. In Lab 4, we are going to look at data preparation for geospatial machine learning. Then Lab 5, we are going to look at an example of machine learning for land cover classification. Then Lab 6, we are going to look for an example of machine learning for regression analysis. Lab 7, we are going to focus on explainable machine learning for geospatial analysis. So this could be for land cover classification or for regression analysis. Then Lab 8, we are going to look at scaling geospatial machine learning workflows. Then for Lab 9, we are going to look at unsupervised machine learning. And then finally, we are going to look at some final project and summary. Right, so to start, we have this is Lab 1. So this is just the introduction to the geospatial machine learning with Python module. So the objective here is just to gain a clear overview of the contents, the labs, and the expected outcomes. So these are things that I've mentioned before about the content and labs. And then we're also going to see how we can access and navigate Google Colab, because this is the environment that we are going to use to run the Python code. And we also just are going to look at how we install libraries in Google Colab. Right, so here we said we are going to use Google Colab. Why Google Colab? Because this is a free cloud-based environment which has got Jupyter Notebook. So Colab is very important because it allows us to write and execute code in a web-based environment. So we avoid the need to do local installations. In addition, we also have access to the GPU. So this is going to be critical when we start to do work on deep learning. Okay, so this is quite important, right? And also we also have a lot of functionalities. For example, there's the cloud storage integration. We can easily import and export data from Google Drive. And again, there's this issue of scalability. We can run intensive tasks on cloud resources. For example, if we want to run the deep learning modules as I've explained. Right, these exercise or modules or labs, you can also run them locally if you want. But for the purpose of this series, we'll be doing most of the work in Colab. Right, and Python also comes with a lot of libraries that we can use for geospatial data analysis and for machine learning. So for this module, we'll be looking mostly at libraries such as Rasterio, the EarthPy, scikit-learn, GeoPandas, Pandas, NumPy. Right, and one important thing is the Colab comes with some pre-installed libraries. So if you want to check the pre-installed libraries, you can just run the code. If you run like this, it's going to show you the pre-installed libraries. So they are quite a lot. They're quite a lot. You can see all that is pre-installed. Okay, and if the library that you want to use is not there, you can also you can install it. So for example, you can install Rasterio because it's not available in Colab. So to install, just run this code, and then it's going to install the library, and then it's going to show if it's successfully installed. Okay, you can also install multiple libraries. For example, you can use pip install, rasterio, ethpy, and any other libraries that you want. Please take note that one of the libraries that we use a lot, GEE map, comes already pre-installed, so that's a good thing. Right, sometimes you may be running a library or package which is not compatible with the Colab or the Python Colab that you are running. So you can also try to install the package which is compatible by finding that package and defining it as follows. Right, and I mentioned briefly about NumPy and Pandas that comes pre-installed, so you can also run these to do your analysis. For example, here I'm just using a synthetic data set to show a relationship between temperature and elevation. So we can import NumPy and the Pandas, and then here we generate about 100 samples showing the elevation and temperature. Right, so if we run this code, we generate these the elevation and temperature. Right. One good thing also about Colab is that you can also use Gemini if we have difficulties with your code, or if you have like a problem writing the code. So for example, let's say we want to create a scatter plot from the data that I have created above. So what you can do, you can click code, and then you can come here, and then where it says start coding or generate with AI, and then you can just click here generate, and then you can write, say, create a scatter plot to show the relationship between temperature and elevation. Okay, so if you click enter, it's going to generate. So note it says use this code with caution. So you always need to check if your code is correct. Okay, so if we run this is just a simple code. So it's going to plot the scatter plot. So here it shows the relationship between temperature and elevation. And we can see as elevation increases, we have a drop in temperature, which is the kind of relationship that we expect. So this is what you can do in Colab. So you can use a Gemini to help you with coding. Right, and also the good thing, as I said, you can also import and export data from Google Drive. So we are going to use this a lot because most of our data will be saved in Google Drive. So always you need to mount your Google Drive, and then it's going to allow you access to your drive. So if you run this, it's going to ask you to connect to Google Drive, and then you can connect, and then it's give you access. Right, sorry, let me just run it so that it doesn't show an error. And this is it. Okay, and then I continue. Now I'll have access to my drive. So my drive is mounted, so you can import any data that you want. Right after that, you can save your work, and your notebook is usually saved automatically, and then it can be saved in this format, the .ipynb. Okay, and this is just the interactive Python notebook. So this is Jupyter notebook format, or you can save also as or export as .py, which is the Python script. Right, and you can also share your Jupyter notebook to say GitHub. Okay, you can save it in GitHub so that other people can have access. Right, so there are a few important things that you have to take into consideration when you are using Colab. So please note that it is a temporal nature. That means when you reconnect or you start a new session, the packages that you have installed have to be reinstalled again. Okay, so if you start another new session, it means you have to install again the library or packages that you had previously installed. Okay, so this is quite important. Another way to maybe solve this kind of solution is, for example, you can use other environments, for example, the Amazon SageMaker, if you have an account there. Okay, and you can also try to install some packages in Drive. This can solve some of these dependence issues, but I've never done that, so it's just a recommendation that I read. It's quite important to install packages at the beginning of the notebook, and then you can also specify the exact versions in your requirement file. So this is good for consistent. Okay, so this is all about the introduction to geospatial machine learning with Python. So in the next video tutorial, we are going to look at some of the basics of Python programming, especially for geospatial machine learning or for geospatial analysis. But this is just a brief introduction that we are going to look at. Okay, so thank you very much for watching. See you in the next video.